This video uses a simple analogy to make the concept of electrical circuits easier to understand. So people find it notoriously difficult to understand electrical circuits because there's nothing really we can see going on. We can see the effects of the electrical energy, but we can't actually tangibly touch, see, feel what's going on. So here we're going to use our little minions to help make this easier to understand. So this whole setup here represents our electrical circuit. The track represents our wires. The steps are our power source, whether that's a cell, a battery or a power pack. The minions are our charge carriers. Normally our charge carriers are electrons. So what's going to represent the electrical current? The current is going to be represented by the rate of flow of minions in this case, because as we know, current is the rate of flow of charge. What's the potential difference, the voltage, going to be represented by? Well, properly speaking, the potential difference, the voltage, is the amount of energy given to each charge. So the amount of energy gained, the amount of gravitational potential energy gained by each minion as it climbs up the stairs is going to represent the amount of energy given to each electron. So here, the gravitational potential energy is an analogy for the energy given to each unit of charge. So let's just switch this on a second. So now we are giving the chargers, we're giving them each energy as they move around, and we're seeing these guys that are trying to come round are getting a little bit stuck. So what could that be representing in this circuit? What would that represent a high level of? That would be a high level of resistance in our circuit. Okay, so the whole purpose of an electrical circuit is to transfer energy. To transfer, if we've got a battery or a cell, chemical energy, to transfer it into another useful sort of energy. For instance, in a simple circuit with a bulb, we're transferring electrical energy, we're transferring chemical energy from a cell or electrical energy from a power pack to electrical energy in the circuit, which will then end up ideally as light energy coming out of our bulb. So there are a couple of ways that we could increase the amount of energy in the circuit. So thinking in this analogy here, what could we do to increase the amount of energy? There's two things. We could increase the amount of energy given to each minion. That means increasing the voltage. So if we increase the height of the steps, we increase the amount of energy given to each minion. That's the same as increasing the voltage, increasing the potential difference. So if each minion has more energy, that means there's more energy flowing around the circuit. The other thing we could do is put more minions in. So if we increase the amount of minions in the circuit, we'd increase the rate of flow of minions, we'd increase the rate of flow of charge. That means we would have increased the current. So those are two ways to increase the energy. As we spoke about briefly earlier, the track here is quite difficult for the minions to descend. That signifies resistance. So resistance is how much the circuit opposes the flow of charge, how much it opposes the current. So if we wanted to increase the resistance, we could make the track narrower, or we could potentially put some obstacles in the way to make it harder for the current to flow. If we wanted to make it lower, if we wanted to lower the resistance, we'd make the track wider, potentially make the track steeper. That's lower resistance. Now, if we put more minions around the circuit, if we increase the current, and there is friction between the minions and the track, what does friction cause? That's right, it causes a heating effect. That's exactly the same thing as if we put a high current through an electrical circuit, because if we've got more and more charge carriers, more and more electrons flowing around the circuit, that means there's more of those bumping into the structure of the wire, and those collisions cause movement of the atoms in the wire, cause kinetic energy in there, and that's transferred as heat. So the more current we put through, the hotter the wires get, and their resistance can go up as well. So bear in mind what we've said about what voltage is. That's the amount of energy given to each minion. Voltage is the amount of energy given to each minion. And the current is the number of, it's the rate of flow of minions. It's the amount of them flowing around the circuit. So what we're going to think about in just a second is what does that mean for how current and voltage behave in series and parallel circuits. So here we've got two very simple circuit diagrams. We've got a series circuit and a parallel circuit. Both of them have one cell and two bulbs. So let's imagine, to start with, that we've got our minions, our charge carriers, our electrons flowing around this series circuit here. So our charge carriers all gain their energy when they pass through the cell. They've only got one path that they can take around the circuit. So all of the electrons, all of the charge carriers, all of the minions have to go through both bulbs. So that means the rate of flow of charge at every point around this circuit is exactly the same. That means in a series circuit, the current is always the same. But these guys each have a limited amount of energy that they give up as they travel around the circuit. So they can give some energy to this bulb and some energy to this bulb. So that means in a series circuit, the voltage, the potential difference, the amount of energy each charge has, is shared between the components. And it's shared depending on how much resistance each component has. In the parallel circuit, we've got two loops. So when our charge carriers have picked up energy from the cell, they can go down one of two paths. So let's say our first charge carrier goes down this path and the second charge carrier goes down this path. That means that the current, the rate of flow of charge, the number of minions down each branch, that is shared in a parallel circuit. But because they've each been given the same amount of energy, they've each gone up the same number of steps, they've each received the same amount of energy in the cell. In a parallel circuit, the voltage in each branch is exactly the same. I hope you found that helpful. Thanks for watching.